Well, hello, Algebrainiacs. Welcome to the Johnson Kendro Video Hour.
But it's not an hour.
Yeah, so don't you stress your little heads. All right, we're going to talk about absolute value, and Miss Johnson's going to start us off.
Okay, we're going to start with the general shape of an absolute value graph. To do that, we're just going to make a t-chart to see what it looks like. We're going to take each x value and substitute it into the absolute value. So the absolute value of -3 will be 3. Absolute value of -2 would be 2, 1, 0, 1, 2, 3, etc. And then let's graph those. It would look like this. So it is going to make a V shape. And that will be true for every absolute value that you graph. Always a V shape with a sharp corner in the middle. And that corner in the middle is actually called the vertex. So this point represents the vertex. My example, the vertex is 0, 0. If you look at this graph, it's a V and it should look exactly the same on both sides. It's symmetrical. That line I just drew in there is called the axis of symmetry. It's a vertical line. X equals 0, and you will notice that this number always correlates to the x value in the vertex. Okay, that's the very, very basic shape. So now we're going to talk about how that shape can change according to some numbers in your equation. All right, that a on the outside, that is going to stretch or compress this graph. Also, if it's ever negative, it will flip it. The number on the inside of the absolute value, we're going to call that h. That thing moves it left or right, so just a slide or a translation. And that one's actually the opposite of what you might think. If you see a plus inside of there, you're going to the left. If you see a minus, you're going to the right. And then k goes up or down. That equation is called the standard form of an absolute value. So because your h and your k are just sliding that thing around, your vertex is going to be at the point hk. So wherever it slides, left or right, up or down, will be your new vertex. We're going to do an example. This one is the absolute value of x minus 2 plus 1. And I've got some steps up there to get us started. We're going to make a shape chart. When you make a shape chart, you are just going to include the y equals a absolute value of x. The a value for this example is actually 1. So I'm going to make a t-chart, plug in our x's, and we're plugging into one absolute value of x. We call it a shape chart because any graph that starts with that a value will have the same shape. We're going to pick just a few numbers, and we're going to pick the positive ones, and I'll show you why in a little bit. It's going to save us some time. Remember, I am plugging these x values into this equation. Okay, I'm not going to do the minus 2 and plus 1 yet. So absolute value of 0 will get us a 0. Absolute value of 1 would be 1, 2, and 3. That would look like this. Using the idea of symmetry, we can go on the other side. So that's why we don't need to plug in those negative numbers. So the shape of our graph would look like this, just like we did up above on the original one. Except that's not our final answer. We have some shifts going on. Inside the absolute value, you see a minus 2. That's an h. And remember, this is the backwards one, so that really means that our graph is going to shift to the right 2 units. When you see a 1 on the outside, that's a k value. It's positive, so therefore it's going to go up 1 unit. So I'm going to take the graph we just sketched on there, the shape, and I'm going to shift it right 2 units. So it was starting here, 1, 2, and up 1. That's my new vertex. And the rest of the shape will look just the same. That's our final answer. Okay, so you make a shape chart, figure out how wide or skinny it is, and then shift it according to h and k. Your textbook is going to ask you to use words to describe how it is a transformation of the parent function. So what changed from the original black dotted graph there? Well, it's a translation because it slid. It didn't shrink or compress or anything. So we will say it's a translation right 2 and up 1 unit. If they ever ask about your vertex and your axis of symmetry, your new vertex, since it went to the right, the new x value is 2, the new y value is 1, and your axis of symmetry now, it's not on 0 anymore. It's going through this number, x equals 2. All right, here's Mrs. Kendro.
Nice job. Kind of a shifty problem there, but we can all manage. All right, this time I have a 2 in front. That A value is different, so we're going to see how that changes. So we're going to still make a t-chart, but this time we're going to put in the whole graph and just see what it looks like. So I'm still going to pick 0, 1, 2, and 3 and use the symmetry idea. So 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Plot those, 0, 0, 1, 2, 2, 4, and 3, 6. Now I have to go on the other side and do the same thing. So here, 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 and look at our pretty picture. Now, do you notice anything different between that and that? Go back again. That one's a lot skinnier, right? So we say this is a stretch because it's being stretched upward. So if the book asks you how is it a transformation, you say it's a stretch by a factor of 2 because it's got that 2 in front of the absolute value. Finding the vertex, same deal, it's still 0, 0, and the axis of symmetry will still be x equals 0. Okay, now one last one here. We are now still going to do a t-chart, x and negative 1/3 absolute value of x. Now we have a hint for fractions to make your life a lot easier. We want to choose multiples of the denominator, because then when you multiply it by the fractions, it will come out a whole number. So 0 is always still a good one to choose. 0 times 1/3 is 0. Then I want to choose a 3 because 3 times negative 1/3 is negative 1. Then choose a 6. 6 times negative 1/3. Choose a 9, and we get whole numbers. If you don't choose the multiples of 3, then you're going to get some fractions. Just makes it a little more miserable to graph. So graphing 0, 0, 3, negative 1. Ah, we're doing something a little different. 6, negative 2, 9, negative 3. So then on this side, we do the same. And look how wide that graph is. And it's upside down. So we have to tell about those two changes. It's a transformation because it's a, we'll say compressing this time because we're making it flatter and wider. So it's a compression by a factor of 1/3, and the negative sign makes it a reflection because normally it would be up here, but we're reflecting it. So it's a reflection, and we say over the x-axis.
Will it always be over the x-axis?
Well, in our problems they will. If there's a y involved there, it might reflect over the y-axis, but we're going to stick with x-axis. All right, vertex. Again, we're at the origin, so 0, 0. Axis of symmetry is always x equals whatever that number is.
Okay, we're going to ask one more question about this. What if our new equation, this looks similar to what Mrs. Kendrow just did, except we're changing a couple things. We're going to change that there's an h value and a k value. So the question asks, what if your equation was negative 1/3 x minus 2 minus 4, absolute value of x. The cool thing about doing your shape charts, Mrs. Kendrow's already got the shape on there for us. Okay, so when we have an h and a k, that just means that we're going to slide, we're going to translate. Again, you do the opposite thing inside the absolute value, so that means go right 2, and then we will go down 4 as well. The new vertex then would be at 2, negative 4, which means our axis of symmetry would be at x equals 2. So I'm going to show you that picture. We're just going to take the vertex and move it right 2 and down 4 units and make the same shape that we had before. Look just like that. Same shape. It is just translated. All right, I think that'll do it.
And that translated into a very fun lesson for today. So you kids have a good night. We'll see you in class.
TTFN, right?
TTFN!